Have you ever wondered how you can be sure that your leak test is actually detecting a leak? The answer lies in something we call a control sample, a package with a perfectly identified leak that we use to determine the test parameters and to confirm that the leak test detects real defects and not false positives. ASTM F2096 describes the principle, but it leaves many questions unanswered. It doesn't say how to create a known defect, what kind of tool to use, or where to buy it. Today, I'll show you two practical methods to create your control sample, and by the end, you'll understand which one is more convenient depending on your type of packaging. The first method is to use a calibrated pin. In our catalog, we offer a model with two ends, one at 250 microns and the other at 150 microns. We tried to make smaller perforations of 100 microns, but the material becomes so fragile that it breaks easily. There are laser techniques that allow for finer perforations, but they turn out to be impractical. They depend on external laboratories, and it's not always possible to control the exact size of the hole. With the pen, on the other hand, any operator can create the sample directly without relying on third parties. To do it correctly, choose an area free of product where bubbles can be clearly observed, especially when the packaging contains a liquid or gel product. Keep the pen perpendicular to the packaging and pierce calmly without applying excessive force. If it's a porous material like Tyvek, avoid piercing areas where a blocking agent has been applied, as we show in another video. Finally, mark the drilling point with a circle to identify it during the test. Method 2. Tungsten filament. Over the years, some packaging engineers shared another approach with us, using a tungsten filament to create a controlled leak and heat-seal packaging. The process is as follows. Place the filament in the seal area before heat sealing. This stage can be the most complex, especially if sealing is done in an automated process. We recommend securing the tungsten wire with a low adhesion adhesive so it can be easily removed after sealing. After sealing and cooling, carefully remove the wire. This will leave a channel with the same diameter as the filament. We usually recommend a diameter of 50 microns, although we can offer other sizes as needed. Tungsten's ideal because it resists heat and doesn't deform, which ensures a stable channel. However, there's an important detail. Sometimes a 50-micron leak can't be seen if there are folds or material blocking the air outlet. In those cases, it's better to use a slightly larger diameter to ensure visual detection. Both methods are valid. The calibrated pen is fast, economical, and practical for routine control. The tungsten filament offers precision in heat-seal packaging, although it requires more preparation. In summary, the ideal method depends on the type of packaging and the level of precision you need. But how do you define the right test parameters? Subscribe and turn on the notification bell so you don't miss the next video dedicated to that topic. And if you need technical support, you can fill out our form at DVACI.com. We're here to help you.